In this example, we're going to get into a little bit more precise definition and illustration of force couple systems. This idea that we can have two equal opposite forces that are parallel to each other, such as what you might have in a cruciform tire iron situation, removing a tire. In that kind of case, or rather removing the lug nuts on a wheel. And in that case, we're delivering a torque to the bolt by having two equal opposite kinds of forces. Right here we've got in this plane of the paper two equal opposite forces. Notice you got F and then minus F. Technically here F is upwards to the right, so the opposite of F is upwards to the right is F, downwards to the left is the opposite of F. Right? And so let's look at three equivalent systems that we have down here. That in the first one on the left, we got two 20-pound forces, equal opposite, so their net translational effect is 0, but they're separated by a 6-inch distance. And so this double-headed arrow that you see here is the equivalent of these two forces that create a couple. Right? And that magnitude of that force is 20 pounds, separated by the perpendicular distance of 6, so the moment is 20 pounds times 6, or 120 pound-inches. Right? Now the double-headed arrow tells us to take the thumb, put it in that direction of the double-headed arrow, and then the curl of the fingers shows us the rotation, which would be, in this case, in a manner that is counterclockwise if you're thinking about looking down the y-axis. Right? So it's going to rotate around the y-axis. Go to another corner of this cube and we got a 30-pound set of equal opposite and parallel forces, and 4 inches away, so there again we've got now 30 pounds times 4 inches, or 120 pound-inches. So that means that with the direction that we've got here, we have two systems that are statically equivalent to each other. And then the last one just takes those same two 30-pound forces but puts them up at the top of the corner of the this cube, and it's going to have the exact same statically equivalent effect of a 120 pound-inch moment, or really in this case torque, around the y-axis. So once again, in a formal kind of way, our force couple system are two equal and opposite forces. The two forces are parallel, and that creates then a moment that's equal to that force times that distance between those two, and it has to, of course, be the perpendicular distance between those two, or something like that. Right? And in that case, it doesn't matter where some moments here, some moments there, some moments there, some moments out here, that will all have the same rotational effect on the body. Not the deformations, that's a different subject matter for a different class, but the static equivalent effect is that this is going to be a moment that's equal to F times D.